Oh, hello there, and welcome to another episode of Calculus BC Math Fun. Today is a beautiful day to look over section 7.2, Area Between Curves.
Whoa, UFO!
Whoa!
A fighter jet?
This is quite peculiar. These flight paths trace the curve of 2 sine x and sine x. The real question is, what is the area between these curves? But how far did they fly?
Well, it looked like it's roughly about exactly 3.141592653.
So to find the area between curves, you need to know the top curve and the bottom curve. So first of all, you need to take the integral of the top curve and subtract it by the integral of the bottom curve, and that will give you the area in between. Because you see the integral of the top curve gives you from that to the x-axis, and the bottom curve gives you from the bottom curve to the x-axis. So when you subtract that from the bigger integral, you get the area in between.
So now, let's apply it to the equations we have. The top curve is 2 sine x. So we're going to find the integral from 0 to 3.14 pi of 2 sine x and subtract the integral from 0 to pi of sine x.
So that integral will give us the area between the two curves, and we can also simplify it down to make our lives a little bit easier. So we could just have the integral from 0 to pi of 2 sine x minus sine x.
dx.
And that will give us the area in between the curves.
Alright, so let's begin the integration process using FTC part 2. So we have the integral from 0 to pi of 2 sine x minus sine x dx. We take the first part, as it can be integrated in separate parts, 2 sine x, and knowing that the derivative of cosine x is negative sine x, the antiderivative of 2 sine x will be negative 2 cosine x. And for the second part, we'll use the same derivative rule, and that'll make negative sine x become positive cosine x.
So far we have negative 2 cosine x plus cosine x. Now, using FTC part 2, we plug in the top limit, which is pi. So we have negative 2 cosine of pi plus cosine of pi. Negative 2 cosine pi is positive 2 plus negative 1 of the cosine pi, giving us 1.
So now with the upper limit we get an answer of 1, and with FTC part 2 we need to subtract the lower limit, which is 0. So we plug in 0 into negative 2 cosine x plus cosine x and get negative 2 cosine of 0 plus the cosine of 0. So negative 2 cosine of 0 would be negative 2, and then that's going to be plus 1. And so negative 2 plus 1 is negative 1.
And now, for the moment we've all been waiting for, to find the final answer of this equation. We got 1 for the upper limit and negative 1 for the lower limit. And to complete FTC part 2, we have to subtract the part from the lower limit from the upper limit. And 1 minus negative 1 is
2.
So now, let's take a look at some other scenarios that might occur. For example, what happens if one of the curves goes below the x-axis? Do we still follow the same path? In fact, we do. Because the upper curve, subtracting the lower curve, even though it's below the x-axis, is still going to give us the area between the two. And here's why that works. The integral of a curve below the x-axis is going to give you a negative number. And subtracting that negative number from the positive integral above the x-axis will give you a positive final answer because it's addition. For example, take the graph sine x and negative sine x. From 0 to pi, sine x is going to be 2. And from 0 to pi, negative sine x would be negative 2. But when we subtract negative 2 from positive 2, we're still going to get a positive answer of 4, which is the area between those two curves.
So now let's find the area between the curves of sine x and negative sine x from 0 to 2 pi. So sine x and negative sine x cross at pi, so we have to do 2 separate integrals. The first integral is going to be from 0 to pi, since that's where the two graphs intersect. So now we have to take the integral from pi to 2 pi of negative sine x minus sine x dx. And when we add that integral plus the integral for the first portion of the graph, the answer works out to be 8.
Say you have to take the integral to find the area between the two curves from their two intersection points that you don't know. To do this, what you would do is set the equations equal to each other. For example, if it was x squared and negative x squared plus 2, set the equations equal to each other and find where they intersect. Here, in this example, it'd be negative 1 and positive 1. And you would use negative 1 as the lower limit and positive 1 as the upper limit, with negative x squared plus 2 being the top curve and x squared being the bottom curve.
Now, even though in every one of these examples, the answer was an even number, that's not always going to be the case at all, except, well, most of the time it's not going to be like that, even close to that. For example, when you take sine x and you go from 0 to pi over 2, you don't get 2 or 4 or 8, no, you get 1. 1's an odd number.
But really, even in the first problem we did, the answer is not really 2. The answer is actually equal to 1/18 of the square root of the quantity, the derivative with respect to x of 36x quantity squared.
Which is 2. Now it's your turn. So switch to section 7.2. Question 9.
When looking at the problem and its graph, make sure to notice that the graphs cross at x equals -2, 0, and positive 2. Now pause the video to work the problem out, and when you're done, press play to see how you did.
So to start off this equation, the first thing we notice is that we have to set up two integrals. One's going to be going from -2 to 0, and the next one from 0 to 2.
So to set up the first integral from -2 to 0, you need to have the integral from -2 to 0 of the quantity 2x cubed minus x squared minus 5x minus the quantity -x squared plus 3x dx, which simplifies to the integral from -2 to 0 of 2x cubed minus 8x dx.
So now for the second integral, we have the integral from 0 to positive 2 of quantity -x squared plus 3x minus quantity 2x cubed minus x squared minus 5x dx, which simplifies to the integral from 0 to 2 of -2x cubed plus 8x dx.
Now to apply FTC part 2 to the first integral. Integral from -2 to 0 of 2x cubed minus 8x. So the antiderivative of 2x cubed is going to be 1/2 x to the 4th, and the antiderivative of -8x is going to be -4x squared. We plug in 0 for the upper limit, and it'll work out to be 0. Plug in -2 for the lower limit, and it works out to be -8. Then we take 0 minus -8, which turns into 0 plus 8, and we get the answer for the first integral to be positive 8.
Now you need to apply FTC part 2 to the second integral, which is the integral from 0 to 2 of -2x cubed plus 8x dx. You antiderive that to get -1/2 x to the 4th plus 4x squared. And then you plug in the upper limit, which is 2, and you get 8. And then the lower limit is 0, so 8 minus 0 is just 8.
So now we have to add the two answers that we got. So when we add 8 plus 8, we get 16, and that is our final answer.
Seriously? Another even whole number?
So that wraps up our video. Thanks for watching, and good luck on the AP test. You'll need it. It'll be positive cosine x, or
Yeah.
positive anything. And to end FTC part 2, we have to subtract -1 from positive 1.
You antiderive that to get negative. You do that, and the
For example, what happens if one of the curves goes below the x-axis?
What does happen?
So now, let's try taking the integral from
Got it?
0.
We're trying to film. Yeah.
So now we have to take the integral from pi.
Figured out how to. Oh.
No, but really, for example, the first. God.
be in it.
No, that's about as far as I can. No, that's about it. Other side of the way. Keep going.
Mm-hmm.
Alright. So, for this. Alright.
Crap.
Negative 2x cubed minus 8x. Right.
I think it's positive 2x
It's- yeah,
cubed.
It's positive 2x cubed, isn't it?
Plus 4x squared. You plug